All right, so like I said in the last video on electron donating groups and electron withdrawing groups, electrophilic aromatic substitution, which I'm going to call EAS, takes up the bulk of chapter 18. And I've put up a general schematic for that right here. Okay, so it's a substitution reaction. So, and it's an electrophilic substitution. So think back to what you know about nucleophilic substitution. A nucleophile comes in and substitutes for a leaving group. Here, an electrophile comes in and substitutes for an H+, a proton. I mean, a proton is an electrophile, right? So let's go through this mechanism. Essentially, what you're going to have to do, the mechanism is going to be the same pretty much every time, but what you're going to have to do in chapter 18 is identify what the electrophile is. That's the first bit. In this mechanism, I'm going to write the H that gets substituted. Obviously, there's an H on every one of these carbons, and with benzene itself, you can't differentiate carbons. So the electrophile will be some positively charged group or strongly partial positive group. There's got to be a catalyst, right? Chapter 17 is all about the amazing stability of aromatic molecules. Chapter 18 is about how we make those react. So we have to have some pretty powerful catalyst in there. But the general mechanism is this. The benzene is going to act as a nucleophile or a base, a Lewis base, and grab the electrophile. This is like the first step in electrophilic addition in chapter 9. Right? First step of electrophilic addition. But now we can't, so now you would expect some nucleophile to come in and bond there, but we would go from an aromatic molecule to a non-aromatic molecule if something bonded there. And so that's not going to happen. What's going to happen is we're going to do an E1 elimination. There's going to be some sort of base, take that proton, re-aromatize the ring, and that gets us our substitution product. Right? So this is last step of E1. So you actually know both of these mechanistic steps already, because you guys know the electrophilic addition mechanism, you know the E1 mechanism, so it's just the first step of electrophilic addition and the last step of E1 put together. And so you go from an aromatic molecule with an H in this position to an aromatic molecule with an electrophile, what used to be an electrophile in that position. All right, I'm going to go through in different videos for all the different electrophiles, but this is the basic one.